Camera's on.
Alright, give me a sec.
And then we need to start recording this call.
Yeah. Here, I'll start recording. Oh, wait, it's already recording. Okay. So, I start from the beginning. Okay. Overrun by the Cat Empire by Connor Mill, Calvin Zoe, and Yuri Phillip.
On September 21st, the students of Renton Prep were assigned a math assignment to show if a female cat can have 2,000 descendants in a matter of 18 months. We're given the following measurements. A female cat has a length of pregnancy of about 2 months. The average number of litters a cat can have per year is 3. The age at which a female can first get pregnant is about 4 months. The number of kittens in a litter is usually 4 to 6, and the age at which a female cat can no longer have kittens is 10 years. Using this information, we can decide if the statement is true or not, and we also need to graph the info to show how we got our answer.
Okay, logical foundation. Plus, we're trying to find out if a cat has 2,000 descendants, if it's even possible, in only 18 months. We need to start with the basic facts of the problem. The poster states that in 18 months, a certain cat can have 2,000 descendants, which is the original mother. The poster says that the cat usually has 3 2-month pregnancy periods per year. Each mother has a litter of 4 to 6 cats, and each cat can get pregnant after 4 months old. And here is the problem poster for the information that we just described. Simplifying and understanding the problem. In order to solve this problem as quickly and simply as possible, we're going to have to take all of the poster information at face value, which means it doesn't get more complex than that. We also need to see how far we can go to get 2,000 cats in whatever way realistically possible. This leaves us with a pattern to follow. The mother is already 4 months old and giving birth, which means her aging is not part of the problem. This means she gives birth by month 2 and her litter begins developing at that point. She cannot, however, get pregnant right after each litter, only 3 times a year. This means she can only give birth 3 times per year, y equals 3b. Next generation can only give birth after developing to 4 months old, which simplifies the problem by making the births happen at the same time. So once 6 months have passed, the original mother and her children give birth, creating the third generation. To make adding up all the litters of females easier, every other cat has a litter of 6, while the rest have a litter of 4. This makes sense because if you round out the number of males and females, the ratio is the same. 6 out of 2 is 3, 4 out of 2 is 2, so the females represent half of the total litter. This leaves us with the following information. At every birth point, there is a birth. So at 2 months, the original mother gives birth. At 6 months, her and the second generation give birth, and so on and so forth until the last birth, which is made by each generation, except for the 6th generation, which has just been born. The problem seems very complicated at first when you see it, but once you can simplify it, you can see that it's easy to solve. Next, our group is going to create 3 different equations and graphs to show the way we each interpreted the information.
Estimation. A cat can have kittens every 2 months. The pregnancy lasts 2 months and averages 5 kittens every litter. That means if she got pregnant every 2 months for 18 months, she would have 45 kittens. In that period, in which half would be females, that could reproduce after 4 months. So if those 22.5 would have 14 months to reproduce, making the total 400 cats, including the male kittens. Here's the graph that shows the percentages.
In my graph, I used a straight lineage method to solve the problem. Instead of representing the litters, I simplified it to only showing the females from each litter, which I decided would be exactly half, just to simplify the problem a bit more, since it's quite complicated. I then subtracted one successive birth from every generation because each generation has one less birth due to the time constraints. Therefore, the fifth litter of the original cat did not have any successive litters, and so on and so forth. The final conclusion is that the original mother had 283 descendants, which is only a tenth of the number determined by the poster. Therefore, that we know that poster was spreading information. Here's my graph using Desmos.
So this is my estimation. I basically split it up into months and generations. So like I've counted for every single month and like how many cats they will give birth to every single month. So after the first 2 months will like the first cat, we're gonna assume that it's only 4 months old. So it's already 4 months old. So we're going to, and then it's gonna produce 6 cats. But then these 6 cats needs to have 6 months to mature, because 4 months they need 4 months to mature, and 2 months to uh, they need 2 months to get pregnant. So that's 6 months in total. So like if you keep on doing the math and then you keep on multiplying, you'll get 216 total cats. And then since you can like one cat can give birth 3 times per year, you multiply this by 216, and like all of the numbers together like by 3. So 200, so as you can see in the picture there, I got 258, because that's the result of 6 plus 36 plus 216. And then you multiply that by 3 to get 774, which is the total cats that I got. This is my graph, which I did in OneNote. So the conclusion is that in our estimations, we chose to represent our own different opinions and answers on how we solve this problem. For Yuri's final answer, it was that the female cat could have 400 cats in 18 months. For Connor's final answer, it was that the female cat could have 283 descendants. For Calvin's final answer, it was that the female cat could have 774 descendants. Even though we all use different strategies and ways to conclude our answers each have something in common. They all prove that there's absolutely no way that a cat can have 2,000 descendants in 18 months. Yeah, we're done.
Okay then. Good job, guys.
See ya.
Yeah. See ya. Bye, Yuri.